A manufacturer of chocolate chips would like to know whether its bag filling machine works correctly at the 407 gram setting. Based on a 13 bag sample, where the mean of that sample is 415 grams, the variance is 784 grams. Is there sufficient evidence at the 0.1 level that the bags are underfilled or overfilled? Assume the population is normally distributed. Important pieces of information are highlighted for you. Mu, what they want it to be, or say it should be, is 407. A 13 bag sample, that's N. Of that sample, X bar is 415. The variance is 784, but variance doesn't do us much good. We need to take the square root of both sides to give us sigma is 28. We're looking for a 0.1 significance. And underfilled or overfilled is going to mean two tails. So let's do our hypothesis test. We think underfilled or overfilled, but certainly not the 407. They would say the mean is the mathematical opposite. It is 407. Alpha was 0.10. N was 13, which leaves us with 12 degrees of freedom. I have 12 degrees of freedom, two tails, and I'm looking at alpha as 0.10. My critical value is 1.782. But because my hypothesis is two-tailed, then my critical value must also be two-tailed, positive and negative. So if the mean in my picture come down the center, then my critical values of 1.782 would be around here. Positive 1.782 with its rejection region, and negative 1.782 and its rejection region. Now I need to find my calculated t. Let's go back to the data. Mu is 407, N is 13, X bar is 415, and sigma is 28. So I plug in 415 for X bar minus 407 divided by S, the standard deviation, of 28, divided by the square root of N, not degrees of freedom, but actual N, which was 13. On the numerator, I will get 8. The denominator, 7.765, and on and on and on it goes, for a final answer of 1.030. 1.030 is just over 1 standard deviations from the mean. Is it in the
So we will fail to reject the null, which means that we were wrong in our interpretation. At the 10% significance level, there is not enough information to say the population mean is different from 407 grams. In other words, There is not enough information to show the bags are overfilled or underfilled. The machine is filling correctly at this time.
The Director of Research and Development is testing a new drug. She wants to know if there is evidence at the 0.05 level that the drug stays in the system for more than 348 minutes. For a sample of 7 patients, mean time the drug stayed in the system was 354 minutes, variance of 529. Let's pick out those pieces of information. Given as seen, alpha equals 0.05. The drug stays in the system according to what it's supposed to do, what they say, is 348 minutes. Sample size is small, 7. Of that sample, X bar is 354, and the variance is 529. Again, we don't want the variance, so take the square root to give us what we want, which is sigma, and that equals 23. Let's plug that into a hypothesis test. We think that things are happening more than, greater than, the proposed mean, and mu was given as 348. So they would say less than, and the null always has equal, 348. Alpha was given as 0.05. There were 7 in our sample. So our degrees of freedom, n minus 1 becomes 7 minus 1, or 6. So let's go find our critical t-value on the chart. Seven people, so 6 degrees of freedom. It is one tail because we're using the symbol greater than, and alpha was 0.05. 1.943. So t will be positive because of the greater than sign, and it is 1.943. If the mean comes down through the center, 1.943 would be over here, and its rejection region. So now our calculated t. Let's go back to the data. X bar is 354. Standard deviation is 23. Plugging that in. 354 is our sample mean. Compare that to your best point estimate, 348. Standard deviation is 23. Divide that by the square root of 7. On the top, I get a positive 6. On the bottom, 8.693, and on and on and on it goes. For division, of positive 0.690. That too in the non-rejection region. We will fail to reject the null. We do.
This means that at the 10% significance level, there is not enough information to say the population mean is different than 407.
Last problem. An engineer has designed a valve that will regulate water pressure on an automobile engine. The engineer designed the valve such that it would produce a mean pressure of 4.1 pounds per square inch. Valve was tested on 6 engines, small sample. Mean pressure was 4 pounds for that sample. Standard deviation of 0.7 for the sample. Is there evidence at the 0.05 level that the valve performs below specifications? Important information. The hoped for mean, or what they say, is 4.1. Sample of 6. In the sample, mean was 4. Standard deviation, thank goodness, no variance this time, was 0.7. Alpha equals 0.05, and we're looking for below, which is going to imply only one tail. So we think it's performing below specifications, less than 4.1. They would say more, greater than or equal to. Alpha is 0.05, N is 6, so we would have 6 minus 1, or 5 degrees of freedom. That is a minus sign. 5 degrees of freedom. 1 tail, because we thought less. Alpha 0.05. My t-value that cuts off the rejection regions is 2.015. Let me highlight for you that we are talking about less than. Less than numbers are negative. On my graph, dashed line would represent the mean, 1 standard deviations, 2 standard deviations. Right here would represent negative 2.015. Our rejection region. Now let's go get the calculated value. Back to the original data. X bar was 4, standard deviation 0.7. X bar is 4, standard deviation 0.7. Other given information, square root of 6. On the numerator, negative 0.1. Denominator, it's about 0.28577, blah, blah, blah. So when I negative 0.350, that falls pretty far from the so we will fail to reject the null.
This means that there is not enough information to show the population mean is less than 4.1.